equal to rate of change of momentum, then realizing that the mass of a particle is not a constant quantity, so we differentiated both M and V. In classical mechanics, what we do, F is equal to d by dt mv, and we take M out, so dv by dt, so this is equal to ma, right? Net force acting on a body is equal to mass into acceleration. But here we have this extra term, right? Because mass is not a constant quantity. Why? Because if a force is acting on a particle, then this force is creating acceleration inside the acceleration of the particle, right? Because of acceleration, the velocity of the particle is changing, and because of that, mass of the particle is changing, right? The force is creating acceleration. Acceleration is the rate of change of velocity. So the velocity is changing, right? If velocity changes, then mass will also change. So with time, mass is also changing. So the kinetic energy will be equal to work done by this force, right? Then we put the value of F from here, m dv by dt plus v dm by dt, right? Then we wrote this as mv dv plus v square dm. How? Because ds by dt is v, so this will become, first term will become mv dv, and ds by dt v, so this will become v square. Now we have two variables here, m and v, right? So I want to convert this integral into one variable. So what I did, I differentiated this, right? After some manipulation here by arranging the terms, that means for after removing the square root sign and differentiating all the terms partially, then we got this expression c square dm. So this becomes, the particle started from rest mass, and suppose the moving mass at certain instant is m, so this becomes c square m minus m naught. So that is equal to mc square minus m naught c square. Okay, so this is the kinetic energy in STR. Kinetic energy in STR is this, right? Suraj, what is the kinetic energy in classical mechanics?
I said
In
half v square.
half mv square, right?
Yes, sir.
And m, there we don't differentiate whether m is moving mass or rest mass. This is simply mass, right? This is simply mass in classical mechanics. But in STR, we have to be very, very careful whether it is rest mass m or, sorry, whether it is moving mass m or it is rest mass m naught. Okay, then we arrange this term as mc square equal to kinetic energy plus m naught c square. Okay, now this m naught is, since m naught is the rest mass, so we call this m naught c square as rest mass e naught. And when a particle starts moving, then it will be having kinetic energy as well. When the particle is at rest, it will be having only rest energy. But when the particle starts moving, it will be having kinetic energy as well. So the total energy of a moving particle is this, right? So we write this expression E as E naught plus kinetic energy. Fine, where E is energy of a moving particle and E naught, that is rest energy of a particle. So this is the Einstein's mass energy relation, famous mass energy relation, E equal to mc square. That when a particle is moving, then its energy will be given by mc square. Right? Remember, this is moving mass, m is moving mass. So this is related to rest mass as this. This. Clear?
Yes, sir.
So this was our derivation. Okay. Now a very important question. Any other student has joined or not? So still only 5 students. A very important question from your examination point of view is that, right, show that the relativistic expression of kinetic energy reduces to that of classical expression for V this. For V very small as compared to C, right? We know that the classical expression of kinetic energy is half mv square, okay? And we also know that this kinetic energy is valid. No, there is no question about that. It is still valid, but it is valid only when this velocity of the particle is very small as compared to c. When the velocity of the particle reaches near to c, then its kinetic energy will be equal to the relativistic expression. And we have to show that this reduces to this. This reduces to this for V very small as compared to C. Is the question clear?
Yes, sir.
So how to get it? Very easy. Put the value of this moving mass in terms of rest mass. So this is equal to 1 minus v square by c square, and c square is already here, right? This is c square minus m naught c square. So one can write this expression as m naught c square, right? I have taken m naught c square common. So this quantity is 1 minus v square c square minus 1 by 2, and this becomes minus 1. Is this step clear?
Yes, sir.
Okay. Now I expand this quantity here, this one, using binomial expansion. So what I will get? I will get m naught c square 1 plus half v square by c square, then plus higher terms of v square by c square, and then minus 1. Okay, is it clear?
Yes, sir.
Now for this condition v very small as compared to c, this higher terms of v square by c square will become negligible. So we will neglect that. So this becomes m naught c square 1 plus half v square by c square minus 1, right? I have neglected the higher powers of v square by c square. So one gets cancelled here. So this becomes m naught c square into half v square by c square, and c square gets cancelled, so we get half m naught v square. This is the classical expression. Is it clear?
Clear, sir.
So this is a very, very important question from your examination point of view. It's not only kinetic energy, any other expression, if you take any other expression, right, any other, whether it is say length contraction, so I move to the next file here. I had uploaded the file yesterday, so did you download? Yesterday lecture was uploaded. Yuras?
Yes, sir. That paint file.
Paint file, right?
Yes, sir.
So we have seen that all expressions, whether it is say Lorentz factor k equal to this 1 minus v square by c square, then this Lorentz transformation x prime, y prime, z prime, t prime, right? X prime is equal to k x minus vt, y prime is y, z prime is z, t prime is k t minus v by c square x. So this is Lorentz transformation, and similarly you have the velocity transformation as well. Ux equal to ux prime plus v, then 1 plus v by c square ux prime. Similarly uy uz. Then you have the length contraction formula, L equal to L naught 1 minus v square by c square. Right? I hope I am writing the formula correctly. I already told you that I can't remember any formula actually. So you should verify this formula. LT, then moving mass is equal to m naught 1 minus v square by c square. Then just we have got this kinetic energy. Now you can see that all these formula, right? All these formula reduce to classical expression for V very, very small as compared to C. Right? Is it okay?
Yes, sir.
So the conclusion is that Newtonian mechanics is valid only when any particle is moving with a speed that is not comparable to the speed of light in free space. Okay? So it's not that Newtonian mechanics is wrong, not at all. It's still valid, but it is just a special case of STR. Right. Now, a peculiar situation arises when the speed of a particle becomes equal to c. If this is the case, v is equal to c, then what will happen? Just see. For example, the moving length is equal to this. So if v is equal to c, then what it will be? Moving length will be equal to what, Suraj?
Yes, sir.
What it will be? If v is equal to c, then moving length L will be equal to what?
So 0 हो जाएगा.
0 हो जाएगा, right? Similarly, what will be the moving mass? Yuras, what it will be?
Sir, infinite.
Infinite. So very peculiar situation is this. And this You can verify other formula also, right? All the above formula that I have written here, by putting V equal to C, you can see what is happening. Now, this is that if a, if an object is moving with speed equal to C, then its length becomes 0. That means it vanishes, it disappears, right? So this is ridiculous. How the object can disappear? Similarly, if a very small particle, right, very small particle of negligible mass starts moving with a speed equal to the speed of light, then its mass becomes infinite. From a very small value of mass, the mass becomes infinite. So what is the conclusion here? The conclusion is a material particle, any material particle cannot move with speed equal to the speed of light in free space. It is not possible, right? V equal to C, not possible. V equal to C possible नहीं है, V greater than C तो सोचने की बात ही नहीं है, right? So what is the conclusion here? That speed of light in free space, that is this 3 into 10 to the power 8 meter per second, is the ultimate speed. Nothing can move faster than this. The speed of light in free space is the ultimate speed. No material particle can move with a speed greater than this or equal to this. That is not possible. So a very important conclusion we have got. Is it okay?
सर अगर फ्यूचर में कभी अगर सर ये पॉसिबल हो गया तो
Yes, might be possible. Why not? जब न्यूटोनियन मैकेनिक्स था तो किसी ने सोचा थोड़ी था कि न्यूटोनियन मैकेनिक्स रॉन्ग भी हो सकता है, लेकिन आइंस्टीन जब आए तो उन्होंने दिखाया कि नहीं, न्यूटोनियन मैकेनिक्स फेल्स when the speed of a particle is comparable to the speed of light in free space. हो सकता है आगे कोई और साइंटिस्ट आ जाए और बोले कि नो, आइंस्टीन्स थ्योरी इज आल्सो नॉट करेक्ट, इट इज ए स्पेशल केस ऑफ ए जनरल थ्योरी. हो सकता है. दैट्स द वे साइंस प्रोग्रेसेस. साइंस का डेवलपमेंट तो ऐसे ही होता है ना.
और सर ये V ग्रेटर देन C हो गया तब क्या होगा?
तब बहुत कुछ हो सकता है. देख लो वहां पर क्या होगा. इफ V इज ग्रेटर देन C, in this case moving length, तो क्या होगा? If V is greater than C, then moving length will become
सर इमेजिनरी हो जाएगा आयोटा.
imaginary quantity, right? It will become an imaginary quantity. So a new area of physics will be developed at that time. साइंस का डेवलपमेंट तो ऐसे ही होता है ना. थॉमसन ने बोला था कि द इलेक्ट्रॉन्स आर एम्बेडेड इनसाइड द एटम, राइट? थॉमसन का तो यही कंसेप्ट था ना पहले. इलेक्ट्रॉन्स आर एम्बेडेड इनसाइड द एटम. रदरफोर्ड आए तो उन्होंने बोला कि नो, इलेक्ट्रॉन्स आर मूविंग इन सर्कुलर पाथ अराउंड द न्यूक्लियस, राइट? उससे आगे आए, उससे और आगे आए बोर मॉडल आया, उससे आगे आए समरफील्ड एक्सप्रेशन आया, राइट? जिसने बोला कि नो, इलेक्ट्रॉन्स आर नॉट मूविंग इन सर्कुलर पाथ, इलेक्ट्रॉन्स आर मूविंग इन इलिप्टिकल पाथ, राइट? उसके बाद आया ऑर्बिटल थ्योरी, दैट वी हैव इलेक्ट्रॉन क्लाउड्स अराउंड द न्यूक्लियस. द इलेक्ट्रॉन्स आर स्प्रेड around the nucleus like electron cloud, right? उसके बाद फिर अनसर्टेनिटी प्रिंसिपल आ गया. So that's the way science develops. और इसमें ऐसा कुछ भी नहीं कि कोई भी थ्योरी जो है वो इनकरेक्ट है. In certain circumstances, that theory is correct. Under certain circumstances, another theory is correct. Under different circumstances, any other theory is correct. ऐसा नहीं है कि कोई थ्योरी गलत भी है. Right? Uncertainty principle is also correct. Right? Under certain circumstances. Orbital theory is also correct under certain circumstances. Bohr model is also correct, definitely under certain circumstances. Bohr-Sommerfeld modification is also correct under certain circumstances. Right? तो साइंस तो ऐसे ही डेवलप होता है. Isn't it? और ये तो बिल्कुल मतलब ये शाश्वत सत्य है. साइंस जो है, कोई भी चीज जो है धीरे धीरे कितनी डेवलप हो रही है. कोई भी हम लोग ले लें, कुछ भी ले लें. पहले जो मोबाइल आता था वो कैसा आता था? फीचर फोन जो आता था
वो बटन वाला
उसके बाद,
सर.
हाँ, उसके बाद देखो कैसे कैसे डेवलप हो रहा है. राइट? कोई सोच सकता था पहले कि इस मोबाइल भी हो सकता है कि हम लोग कहीं भी रहें और बात कर सकते हैं, है ना? मोबाइल और वो जो फीचर फोन था उसके बीच में एक और आया था मैसेज भेजने के लिए. क्या बोलते थे उसको, जो जनरली बेल्ट में लगाते थे? कहीं मैसेज भेजना रहता था, है ना? बेस फोन में क्या था ना, बेस फोन में जो था कि घर जहां पर बेस फोन है वहीं से बात कर सकते हैं या मैसेज भेज सकते हैं. इन बीच में एक आया था ना, बेस फोन के बाद में और मोबाइल के पहले.
पता नहीं सर उसके बारे में.
एक छोटी सी डिवाइस रहती थी जिसमें मैसेज टाइप करते थे, फिर वो एक सर्वर पर जाता था और वहां से वो दूसरे आदमी. हाँ,
पेजर.
पेज है. राइट, यस, पेज है. राइट. पेजर के समय तक लोग नहीं सोच सकते थे कि मोबाइल भी हो सकता है. वो तो था केवल मैसेज ट्रांसमिट करने के लिए. तो दैट्स द वे साइंस डेवलप्स.
अब तो फ्लैट आ गया सर.
हाँ, अब तो खैर आगे चलकर तो और भी ऐसे ऐसे ट्रिमेंडस डेवलपमेंट हो सकते हैं जिसकी हम लोगों ने कल्पना भी नहीं की होगी, है ना? आजकल तो बल्कि ये कॉमन हो गया है कि आप अपने ऑफिस में हैं और घर के जितने इलेक्ट्रॉनिक गैजेट्स हैं सब आप ऑफिस बैठे बैठे कंट्रोल कर सकते हैं. राइट? ऑफिस से चले तो अपना घर का एसी ऑन कर दिए, लाइट्स ऑन कर दिए, लाइट्स ऑफ कर दिए. So this happens only through research, right? ये रिसर्च से ही पॉसिबल है. A lot of scientists, a number of scientists have devoted their time and still they have been devoting their time day and night to develop new things. Okay, fine. So a very important thing we have understood today that all the STR, all the expressions in STR reduced to classical expression for V less than C. Okay, now related to this, we have another very interesting topic which is not explicitly given in your syllabus, but that has been asked many a number of times, right? वो हम लोग देखते हैं. Right? One is suppose we have total energy, we have a moving particle, right? We have a moving particle. There is a moving particle, right? A particle is moving with certain velocity, say v, and moving mass is this, right? Then the energy of this particle is given by this mc square. So this is equal to m is equal to m naught 1 minus v square by c square, c square. And the momentum of this particle, now see, just pay attention. momentum of this particle will be mv, where m is the moving mass, and this will be equal to this 1 minus v square by c square. Sorry, this will be equal to v. So v. So you can see the momentum expression also changes in STR. It's not only mv, it's m naught v by 1 minus v square by c square. Right? Now consider two cases here. Right? One case is, so I am considering two cases here. One case is rest mass of a particle is 0, right? And this particle is moving with speed less than c. समझे? I am considering a particle whose rest mass is 0. Rest mass is 0 means that is massless particle having no mass. Right? Clear hai?
Yes, sir.
Yuvraj? Now in this case, what will be the energy and momentum of the particle? If I put this m naught equal to 0 and v less than c, then what I will get for E and P? Shashwat? शाश्वत?
यस सर, वो तो नेग्लिजिबल हो जाएगा सर.
नेग्लिजिबल हो जाएगा.
ग्ले-
सूरज?
सर मास नहीं है तो 0 ही होना चाहिए था, एनर्जी और मोमेंटम.
दोनों 0 होना चाहिए definitely if you put this. Right? If you put m naught equal to 0, then you will be getting E and P both 0. But if m naught is equal to 0 and V is equal to C, अब क्या होगा? Yuras?
Sir, undetermined term. 0 by 0.
And 0 by 0. Suraj?
यस सर,
0
अनडिटरमाइंड.
by 0.
या फिर सर
शाश्वत?
मास 0 है तो सर एनर्जी वही 0 रहेगा.
ऋषभ?
Yes, sir. 0 by 0.
0 by 0. Right? This will be 0 by 0 and this will also be 0 by 0. Right? What does it mean? That these are indeterminate. Indeterminate. Right? E and P are indeterminate. Indeterminate का मतलब क्या हुआ? We cannot determine. Right? We cannot determine. इसका मतलब ये नहीं हुआ कि ये पॉसिबल नहीं है. Right? The energy and momentum of that particle will be something, although we are not able to determine. Indeterminate का मतलब ये नहीं हुआ कि वो एग्जिस्ट कर ही नहीं सकता है. Is it clear? Indeterminate doesn't mean if a quantity is indeterminate, that doesn't mean that that quantity is not existing. इसका मतलब ये नहीं है. Right?
Yes.
That quantity might exist. We are not able to determine it. That means E and P can have any value. कुछ भी हो सकता है. हम लोग उसको डिटरमिन नहीं कर सकते हैं। राइट? So once again, STR has clarified here and put a very remarkable theory that massless particles can exist provided they are moving with velocity equal to the speed of light in free space. Right? Massless particles can exist, but according to this expression here, if the particle is moving with a speed less than the speed of light in free space, then that massless particle will be having zero energy and zero momentum. That means if a particle is having some semblance of mass, right, then it cannot move with a speed equal to the speed of light. So from here also we are getting the confirmation, right, that a material particle cannot move with a speed equal to the speed of light in free space. Only massless particles can move with a speed equal to the speed of light. और massless particles उसी स्पीड से मूव ही कर सकता है, दूसरी स्पीड से नहीं मूव कर सकता है, because if it starts moving with speed less than the speed of light in free space, then its energy and momentum will be zero. Right? Getting?
Yes, sir.
So just see that how our day-to-day experience till now, कॉमन सेंस जिसको हम लोग बोलते हैं, वो कॉमन सेंस कैसे एक के बाद एक जो है वो कॉमन सेंस अनकॉमन होता जा रहा है STR में. Right? So Einstein has defined this. What is common sense? Common sense is a collection of prejudices, right, that we get till the age of 18. है ना, 18 साल की उम्र तक जो हम लोग सीखते हैं, that's a collection of prejudices. After 18 years, right, कहने का मतलब है कि when your knowledge is getting enhanced, then you should think beyond that common sense. क्योंकि during after that time, that common sense will become uncommon. No, it's uncommon नहीं है to think about massless particles, any particle which is not having any mass, any rest mass, right? And let me tell you that we have the existence of massless particles. Photon is a glaring example of massless particle. Right? Example is photon here. And with the help of photon, Einstein explained that photoelectric effect. Right? तो ऐसा नहीं है कि ये STR जो है वो हवा में बातें कर रहा है. Right? Why Einstein is regarded as the greatest scientist? Only because he thought something which was beyond the capability of any other scientist.
Sir, so at V equal to C, any massless particle can possess any value of energy.
Yes, it can have any energy and momentum. It can have any value. Right? But later we will see that even if we cannot determine E and P separately, but we may find a relation between E and P for massless particle. That, right? E and P can have any value, but there may be a relation between E and P that a massless particles satisfies. ये अभी हम लोग देखने जा रहे हैं. Okay, so the point is here, Newtonian mechanics doesn't predict the existence of massless particles. STR predicts, right? So as I told that a massless particle can have any value of E and P, but there might be a relation between E and P for massless particle, right? Let us see that. For that, we are going to play with these expressions E and P. E and P के साथ हम लोग अब प्ले करने जा रहे हैं ना, इसके साथ कुछ खेल कूद करते हैं E और P के साथ में और देखते हैं क्या होता है, right? So starting from this equation 1 and 2, let us see what we are going to get. From 1 and 2, let us find a quantity E square minus P square C square. ये कितने के बराबर होता है, right? Can you do? I hope everybody is having pen and pencil. All 5 students. Ashish has just joined. Ashish. Ashish, are you here? Ashish? Okay, Rishabh, Shashwat, Yuvraj,
Yes,
Suraj
sir.
and Shrestha.
Yes sir, yes sir, yes sir.
What I have told you that take a square of E, take a square of P and tell me what you will get for E square minus P square C square. A very simple expression you will get.
Sir, M naught square C4.
Good. So you have got this M naught square C4. I will wait for all of you. Everybody should get this expression. Everybody has got? Ashish, are you here? Ashish?
Yes, sir, I got it.
So Yuvraj has got it.
Yes, sir.
Rishabh also.
Yes, sir.
Yes sir.
Right? Okay. So what we have got that the total energy of a moving particle E is equal to M naught square C4 plus P square C square under root. Right? Very important relation. In examination, it has been asked, derive this expression. Right? And you know that this M naught C square is also equal to raised mass. So the first expression is E naught square. Right? We have just seen that E naught is equal to M naught C square. Okay. Now for a massless particle, M naught is 0, right? Rest mass is 0. So what we are getting from here? We are getting E equal to PC, right? Because rest mass is 0, so this rest energy is 0. E naught is 0. Is it clear?
Yes, sir.
So we have a relation between energy and momentum of a massless particle. The energy and momentum of a massless particle is related to this quantity, E equal to PC. Right? Is it okay? Right? Yuvraj?
Sir, but initially it has the value 0 by 0. Now it has equal to PC.
Separately. 0 by 0 means indeterminate. That doesn't mean that quantity doesn't exist. वही तो मैं स्ट्रेस दे रहा हूं. Separately, E and P are indeterminate. That means they can have any value. ऐसा नहीं है कि उसका वैल्यू नहीं होगा. Right? 0 by 0 means that is indeterminate. We cannot determine it. Cannot determine का मतलब ये थोड़े हुआ कि उसका कोई वैल्यू नहीं है.
Yes, sir.
Right? Now you can see everybody knows this, that the energy of a photon is equal to, can you recall, energy of a photon is equal to h nu. Right? And this is something extra which we will understand in quantum mechanics. ये कैसे आया? Because the energy of a massless particle is given by P by C, right? And you know that the de Broglie wavelength is given by H by P, right? So if we put P equal to H by lambda here, then this becomes this. So H C by lambda, and C by lambda, that means speed by wavelength is frequency. So E equal to H nu. That the energy of a photon is given by h nu. So all these are coming because of STR. Right?
Yes, sir.
So let us save this also. I will upload this after the class. So now we have just derived that the energy of a moving particle is given by E naught square plus P square C square, right? This is general formula for a moving particle. And for a massless particle, E naught will be 0, so E will be equal to PC. And just earlier, we had derived that the energy of a moving particle in terms of kinetic energy is given by this. याद है ना? ये कौन सा फॉर्मूला है? E equal to mc square, E naught is m naught c square, and this kinetic energy which we had derived earlier. So in STR, in STR, energy and momentum are related by this quantity, right? Energy and momentum relation, right? And this one is energy, total energy and kinetic energy relation. Okay. In STR, this is energy and momentum relation, first one, right? So depends on the context of the question, right? Still, I have not solved any numerical example that I will solve in the next class tomorrow, right? I will try to solve some numerical examples here. Okay. So we have these two formula. अब अगर क्वेश्चन में suppose if momentum is given and if you have to find the total energy, then you should use the first formula. And if in question kinetic energy is given and you are required to find total energy, then you should use this formula. है ना? Many times question has been asked that find the rest energy of an electron. क्या होगा? Rest energy of an electron is equal to m0 c square. Now put the value of electron mass kg and this c square, that is 3 into 10 to the power 8 meter per second square, and find this value, right? Okay, so this I am leaving to all of you, that you should try to find this. Okay, this will come out to be, if I recall it correctly, then 0.511 up to 3 decimal place mega electron volt, right? In STR, the energy is expressed in terms of either mega electron volt or giga electron volt. This is a homework to all of you to get this, right? I'm writing this homework. How to get this? Put the value of C here. So whatever you will be getting, that will be in joule, right? और जूल को फिर हम लोग कन्वर्ट करेंगे इलेक्ट्रॉन वोल्ट में. Can you do it, Yuras?
Yes, sir. So 27.33 into 10 to the power minus 81 joule.
Joule. Then convert that in terms of electron volt. 1 electron volt is equal to 1.6 into 10 to the power minus 19. 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. जो इलेक्ट्रॉन का जो चार्ज इलेक्ट्रॉन वोल्ट, राइट? इलेक्ट्रॉन वोल्ट का मतलब ये ना, एक इलेक्ट्रॉन का चार्ज इनटू 1 वोल्ट, वो इतना आएगा. So this question has also been asked in different ways. Find the rest energy of an electron, find the rest energy of a proton, find the rest energy of a neutron, like that. So इसको कर सकते हो ना तुम लोग?
Yes, sir.
Okay. Now, one thing that I want to convey here, that these two are the expressions of total energy, and दोनों सही हैं. One is the relation between E and P, and the other is the relation between E and kinetic energy. So both are correct, right? No problem. हाँ, इसको कभी-कभी हम लोग याद रखने के लिए, है ना, एक हम लोग बेहतर निमोनिक भी डिजाइन करते हैं, राइट? जस्ट सी हाउ टू रिमेम्बर दीज टू एक्सप्रेशंस एंड ऑल ऑफ यू विल लाइक इट. मैं क्या करता हूं यहां, राइट? आई टेक ए राइट एंगल ट्रायंगल लाइक दिस, राइट एंगल ट्रायंगल, जिसमें बेस जो है E0 है और ये जो है वो PC के बराबर है. तो जो हाइपोटेन्यूज होगा वो क्या होगा? अंडर रूट ई नॉट स्क्वायर प्लस पी स्क्वायर सी स्क्वायर, राइट? सही है ना?
यस सर।
तो ये ई हो जाएगा ना, ई इज इक्वल टू दिस, हो जाएगा ना?
यस सर।
अब मैं क्या करता हूं, कीपिंग दिस एज सेंटर, राइट, कीपिंग ए एज सेंटर एंड ए बी एज रेडियस, एक आर्क ड्रॉ करते हैं। एक आर्क ड्रॉ किए तो ये कितने के बराबर होगा?
ई नॉट।
ई नॉट, गुड, ए बी के बराबर। ये ई नॉट है और इसको ले लिए काइनेटिक एनर्जी। तो अब ये पूरा हाइपोटेन्यूज कितने के बराबर हो गया? ई नॉट प्लस काइनेटिक
E naught.
एनर्जी, दैट इज ई। तो दोनों तरफ से मेरे पास आ गया, राइट? हमें दोनों फॉर्मूला यहां से मिल गए। So that's the way we actually understand this. है ना? This is just an exploration, nothing else, है ना? इस तरह से कोई भी फॉर्मूला अगर तुम्हें मिले, मान लो तुम्हारे पास एक ही क्वांटिटी के दो फॉर्मूला है, देन यू शुड ट्राई टू गेट दैट पिक्टोरियली, कि पिक्चर के जरिए उन दोनों फॉर्मूला को किसी तरह से समझ सकते हैं क्या? जस्ट एक्सप्लोरेशन, है ना? और यही सब चीजें जो है रिसर्च में काम आती हैं। द मोर यू विल एक्सप्लोर, द मोर योर माइंड विल बी रिसर्च ओरिएंटेड। फाइन, ओके। So one last topic that I can explain here is, and that has also been asked in examination, that is relativity of simultaneity. Relativity of simultaneity. What is this? Again, our favorite picture here, S and S prime. Right? The two observers are here. Okay. Now suppose two things are happening in nature at different location. Two things are happening, right? Same, say bursting of firecrackers. Two things are happening. Okay, so suppose this observer who is in the frame of reference S, he sees that one incident is happening at time t1 at location x1, and the other event is happening at time t2 at other location x2. Is it clear? So understood the problem, Suraj?
Yes,
Yes,
sir.
Suraj.
Yes,
Two things are happening in nature at different location, and the observer who is in the frame of reference S, he finds that the first incident is happening at time t1 at location x1, and the second event is happening at time t2 at location x2. Now, what will be the timing of the two events as seen from the frame of reference S prime? So, Shashwat, you should tell here which transformation we have to use, inverse or direct? Shashwat?
Yes sir.
Which transformation?
Direct transformation.
Direct.
Yes, sir.
Ashish? Ashish, are you here? Ashish? Rishabh?
Yes, sir.
Yes, sir.
Which trans? Ashish, what you are doing? Ashish? Ashish? Rishabh? Which transformation has to be used?
Direct.
Suraj?
And direct transformation.
Fine. Good. So this will be equal to T1 prime will be equal to K T minus V by C square, of course T1, and then X1, and T2 prime will be equal to K T2 minus V by C square X2. Okay. Now let us try to find what will be the difference of time. T2 prime minus T1 prime will be equal to what? So if I take the difference, then on the right hand side, I will be getting T2 minus T1 minus V by C square X2 minus X1. Okay? Is it okay?
Yes, sir.
Now suppose the two events are happening at the same time as seen from the frame of reference S. Right? The two events are happening at the same time. So what will happen to this expression? युवराज क्या होगा यहाँ इस एक्सप्रेशन में?
So what's the
Question is suppose the two events are happening at the same time as seen from the frame of reference S. तो क्या होगा?
the term K becomes 0, K T2 minus T1.
This will T2 minus T1 will become 0, right? Because T1 is equal to T2. K कैसे 0 हो सकता है? K तो नहीं ना 0 होगा.
Not
K,
K. T2 minus
right.
T1.
This will become 0, right? So this will become V by C square X1 minus X2, right? This will become in fact minus V by C square X2 minus X1. So मैंने minus sign यहाँ कर दिया.